Hi, and welcome to the second part of this two-part video series looking at moderation, mediation, analysis by IBM SPSS statistics. In the second part, we're looking at mediation analysis. If this is a new area for you and you haven't looked at moderation, mediation analysis before, I would recommend that you start at part one. It's a bit of a gentler introduction to this area. Mediation analysis is a natural follow-on for moderation analysis, and it is a little bit more complex and involved. Secondly, again, a reminder, a prerequisite for this is that you should have a good grounding in linear regression, understanding linear regression output. If you haven't got that, you might want to start learning about it and go to our website and look at one of the videos that we've already done on that area. And lastly, before we get started, you should be aware that we're using the process macro tool, which can be downloaded from www.processmacro.org. This is a non-standard SPSS tool which acts as a plugin to SPSS developed by Andrew F. Hayes. And again, part one goes into detail about how you can download and install that. Okay, let's look at understanding mediation analysis. So in the first video, we were focused on moderation analysis, and we explained that a moderating variable or moderator is one that contextualizes the relationship between an independent and dependent variable. In contrast, a mediating variable is one that can be used to represent the hidden underlying cause of a relationship between an independent and a dependent variable. So a mediating variable explains why a relationship exists. It provides a reason for the effect of a given factor upon some outcome of interest. A lot of analysts would regard a mediator as something that the independent variable causes or creates, and the mediator variable then goes on to influence the dependent variable. So it's implying that there's an indirect relationship between the original independent variable, what's called the focal independent variable, and the outcome of interest, the dependent variable, and that there is this mediating variable in between them, which is actually the real driver of the effect that we're seeing in the outcome variable. So examples of this might be, you might notice in your analysis, a relationship between new exercise regimes and an increase in respondent self-esteem. Is this relationship mediated by the degree of weight loss that the exercise regime causes, which in turn increases self-esteem? So we would be saying that weight loss here is actually the mediating variable. Or an alternative is that a researcher discovers that income is related to life expectancy. Does having more money literally make you live longer? Or is this relationship mediated by the fact that those of higher incomes can afford better healthcare treatment? So a perfect example of where mediation analysis might be employed. Mediation analysis can be represented in the graphical form. Here the graphical form is a little more complex than the one that we saw earlier with moderation analysis. But these diagrams are really very useful because firstly, they introduce us to some key terminology, and secondly, they directly describe a lot of the output that we see when we perform the analysis itself. And the first bit of terminology we want to introduce is this one here where it says total effect. This represents a regression using the original focal predictor and the dependent variable, so the independent and dependent variable, the predictor and the outcome, and it's just a simple linear regression of one variable being regressed on another. So this is without the mediator present. When we include the mediator, we end up with a more complex diagram here, and the first one we're going to talk about is what's called the direct effect. This is labeled pathway C here, and this is again the relationship between the original focal predictor and the outcome of interest, the dependent variable, with the mediator variable present. So this is more like a multiple linear regression where we're using two variables to predict an outcome. It's a simple multiple linear regression, but there are two variables. So the coefficient here is slightly different from the one up here because this one is present. We're controlling for the effect or the presence of that additional variable. Then we have pathway A, which measures the relationship between the original focal predictor and the mediator variable or underlying cause variable, if we think that exists, and the mediator itself, the underlying cause variable, and the outcome variable, the dependent variable itself, which is labeled here pathway B. If these pathways are literally multiplied together, if these effects are multiplied together, literally A times B, that creates an indirect effect. That creates a number of an indirect effect, And if that is shown to be statistically significant, then we can say that this relationship is mediated by this mediator variable. In other words, that the mediator variable effectively represents an underlying cause that drives that outcome of interest. So we're really focused on the indirect effect. That's a kind of the final part of our analysis. So let's have a look at where that takes us. For the demonstration part, we're returning to the earlier dataset that we introduced in the moderation analysis video. We're using the employee data.sav dataset, and this time we're asking the question, is the relationship between education level and current salary mediated by the employee's starting salary? An individual's starting salary is likely to be directly related to their education level, of course, as well as their experience. And therefore, the relationship between the three factors would look something like education causes your starting salary or influences your starting salary, which in turn influences, of course, your current salary. It is reasonable to assume that starting salary may mediate the relationship, therefore, between education and current salary. So when we look at that graphically, in terms of the graphical form that we introduced earlier on, when we look at the total effect output, we're looking at the relationship between education and current salary on their own, without the mediator variable starting salary included. And then we're going to see some output related to education with our mediator variable starting salary and our current salary. So we're going to see output for how well education predicts starting salary, how well education predicts current salary with starting salary present. That's a multiple linear regression, so with that present, with it controlling for starting salary. And we're also going to see total effect, so we're going to see education against current salary on its own, and we're also going to see, of course, the critical output, which is the indirect effect, and we're going to be very interested in whether or not this indirect effect is statistically significant or not. Okay, let's take a look at how we do that in SPSS using the specially downloaded and installed process macro tool. So here's the data set that we used earlier in the moderation analysis. This time we're doing a slightly different type of analysis. We're doing mediation analysis, and we're going to be using education to predict current salary and find out whether or not that relationship is mediated by beginning salary. So to do that, we're going to go to Analyze, down to Regression, and then to Process, which is the Process Macro tool. And we're going to specify the analysis in the usual way. We're going to say what our dependent variable is. It's our Y variable, which is the current salary. Our X variable, of course, is the thing we're trying to use to predict. That is education level, and our mediator variable is beginning salary. The idea being that education level gets you your beginning salary, and that in turn predicts your current salary. This time we're doing a mediation analysis, so the type of model is lots and lots of different models that you can have a look at. That there's 92 different model types here. This is actually for standard basic mediation analysis. It's model number 4. Just need to remember that. Click that on. There is going to be some bootstrapping that goes on here. We don't need to add anything else in there. We could control for another variable. That's why I've got month since hire here. If I wanted to control for that other variable, I could add that as a covariate. Just a few options to be aware of. If I click on options here, I'll ask for the total effect model to be shown explicitly. You will see some output for total effect anyway, but I'll see the total effect model explicitly. And you can also ask for things like standardized effects if that's interesting. You've got lots of other types of output you can choose here. I'm not going to dwell on that. I'm just going to go for a pretty basic analysis here. Click continue, click OK, and wait for the analysis to run because it takes a bit longer as there's some bootstrapping goes on, which is going to involve resampling the data in order to create confidence intervals. Now let's have a look at the output itself. So the initial output here just shows how the model's been specified. We can see it's model number 4. Our Y variable, our dependent, is salary. Our predictor field is education, and our mediator field is beginning salary. There are 474 cases. And the first piece of output that we see is where the outcome variable happens to be beginning salary, and we're using education to try and predict that. This is just standard regression output, but this is basically path A that we saw in our little graphical form diagram here. This is education predicting starting salary. So this is the output that relates to that. And what do we see? Well, we see an R value of 0.6, so it's quite strong correlation. That leads to an R square of 0.4. That's statistically significant. We can see a P value here. This is our omnibus test. We have an F test. And then we have model coefficients themselves. We have one for an intercept, of course, statistically significant. Notice that we have lower and upper confidence intervals for these coefficients. And here we have education, basically saying that every 1 year of education above the intercept gets you $1,727 on average, and that is statistically significant. We also have a standardized coefficient here, which is of course exactly the same as our R value at this stage, because this is just a simple linear regression with one term included in it. Okay, what about the output beneath that? The output beneath that is now looking at salary, but we're using both education and beginning salary. So now it's saying that every 1 year of education gets you about $1,000, and every $1 of beginning salary gets you about $1.67. So these values, of course, aren't exactly the same, because now we have an additional variable in there. They're all statistically significant, and we have some standardized values down here showing us now basically effectively, so the partial correlations, how much beginning salary is really dominating in this multiple linear regression, because education coefficient now has dropped from 0.6 down to 0.17. Then we have the total effect model that we asked for earlier, we explicitly asked for. This is where salary is being predicted using just education, and it's saying if you want to predict people's current salary, then every 1 unit year of education will get you $3,909 on average. Now education, the coefficient associated with that is coming in at 0.66, so pretty strong correlation here, of course, which is exactly the same as the R value up there. R square value of 0.43, of course. And then we have our kind of key output here. This is the total direct and indirect effects of X on Y. So when we look at the total effect, it's saying that basically you get 3,909. That's the effect of each 1 unit increase of X on Y, which is of course X being education and Y being current salary. We also have some upper and lower confidence intervals that we can see here with this. And then we have the direct effect that we saw earlier on, which is X on Y. So again, it's just the direct effect. When we look at the effect of education to predict Y in the presence of beginning salary. And then we have critically our indirect effect. So our indirect effect here is showing an effect of $2,889. So when we look at the effect of 1 unit increases in education mediated by beginning salary, we have this value that's coming up. Is this statistically significant? Well, we're not getting a stats test here per se. There are certain statistical tests associated with this, but the convention is instead to look at the upper and lower confidence intervals of this coefficient effect here that's shown. And basically, because these are both positive numbers, so we're saying that I think 95% confidence intervals are going from 2,458 to 3,359. It's saying that the within the population, the true value is likely to lie within a interval like this. They're both positive. They don't contain the value 0, so not like one's minus and one's positive. And because that is the case, we say that that is statistically significant. If this was a negative effect and these were both negative numbers, again they wouldn't contain the value 0, and we'd say that was statistically significant. But if one confidence interval is minus and one is a positive number, then it's generally non-significant. And we have a standardized effect here. So what we're saying is that that beginning salary does mediate the relationship. It is a significant mediator of the relationship between people's education and their current salary. There is a mediation effect here. We can have a little look at this output in a little more detail. We'll just skip to the slides and we'll go into it in a little bit more detail. So returning to some of the output that we just viewed again, we're just going to take a closer look at it, and we can see where the coefficient for the indirect effect is actually calculated from. You remember it's actually the product of two regression coefficients. The first one is path A, where education is being used to predict our mediator variable, starting salary. And it's simply saying here is a coefficient 1727. For every 1 unit increase in education, you get $1,727 off your beginning salary. And the second one is a direct effect. This is education and starting salary being used to predict current salary. Okay, it's our target dependent variable. And here it's saying in the presence of education, for every 1 unit, every $1 of beginning salary, you get $1.67 or $1.67 in your current salary. What happens if you actually multiply those two values together? You're going to get 2,889, which turns out to be exactly the number that we're seeing in the indirect effect. So that's where that number is actually coming from. And as we said earlier on, if the confidence intervals do not contain 0, that particular variable there, which is our mediator variable, is regarded as a significant mediator. We can actually go a little bit further and look at the relationship between the indirect effect and the value in the total effect and work out what proportion of the total effect is actually accounted for using the indirect effect. And that's simply a case of taking the total effect, the indirect effect, and dividing the indirect effect by the total effect. That will give you the ratio of one to the next, if you like. That gives you a value of 0.739, which is equivalent to, when you multiply by 100, 73.9%. And that is the percentage of the total effect that the indirect effect accounts for, which, if is literally an effect size. So it's telling us how much it's contributing towards it, which is very interesting. Lastly, we can talk about what type of mediation we've detected. Full mediation is when path AB is significant but path C is not. It's not unusual to find a situation where the focal independent variable no longer has a significant relationship or a significant effect upon the dependent variable when the mediating variable is also present. In other words, when you're running an analysis effectively using both of them as predictors. And if that's the case, but the indirect effect itself is statistically significant, then that's called full mediation. Now, in our case, we actually found that when we did our analysis and starting salary and education were both present in the equation, that education made a significant contribution towards the model. The value was less than 0.05. It was a significant predictor, and the indirect effect, of course, using the confidence intervals we found, was also a significant contributor towards the model, had a significant effect upon the model, upon the dependent variable. That's called partial mediation. Thanks for watching.